Hi, I'm Yue Chen from University College London. My topic today is parallel recognition of Mandarin tones and focus from continuous F0 contours. In tone languages, local F0 contours are mostly controlled by both lexical tones and prosodic focus. In such concurrent encoding system, tone and intonation jointly shape syllable-sized pitch targets that can generate surface F0 contours in speech production. Then, how exactly both tone and focus can be decoded in perception from F0 contours? Are tones and focus separately recognized, or are they perceived together in parallel? Are they processed based on syllable-sized units or sentence-sized units? In this study, we try to indirectly answer questions by computationally simulating the perceptual recognition of tone and focus. We applied the support vector machine model to recognize tone and focus from F0 trajectories in an experimental Mandarin corpus which was designed with 4 tones and 3 focus patterns. 3 sub-experiments were run to compare the recognition strategies: recognizing tones only, recognizing focus only, and recognizing tones and focus at the same time. The input are syllable-sized F0 contours in hertz or in semitone. From the result, the first finding was that the recognition was better in semitone than in hertz. The rest of the results are all based on semitones. From Figure 1, the recognition rate of tones only was 88% overall, and the rate of focus only was 77% overall. Figure 2 showed the breakdown of recognition rates of tones and focus across different focus and tone conditions. This indicates that the perception of tone and focus from continuous speech is likely dependent on each other. Under post-focus condition, recognition rates of all tones dropped much except tone 3. Rates of pre or neutral focus was always the highest across different tones. On-focus got higher rates than post-focus on the tone 2 and tone 4, while post-focus was higher on the tone 1 and tone 3. The overall recognition rates of tone and focus combinations were 88% for tone and 77% for focus, which is similar to tone or focus only task. Detailed accuracy for each tone and focus were also similar to previous experiments, except that the rates for post-focus syllables dropped from 59% to 49%. Figure 3 is a breakdown of the recognition rates for combination task. The pre or neutral condition got the best performance, and there is a significant drop in the on-focus condition when the tone was either tone 1 or tone 3. In the post-focus condition, the recognition rates of all tones dropped to around or below 50%. In particular, tone 3 is very well recognized when post-focus in tone-only recognition task, but tone 3 post-focus combination is poorly recognized, which indicates that the combination is hard to be recognized as post-focus. In this study, we applied SVM to recognize Mandarin tones and focus based on local syllables. Our results show that, at syllable level, the overall performance of parallel recognition was no worse than that of tone-only or focus-only recognition. The varied recognition rates indicates that the perception of tone and focus is dependent on each other, and the heavier drop of focus recognition rates in the combination task may be due to that focus perception are more vulnerable to tone change. In future work, we will incorporate the recognized tone and focus from preceding syllables as input to see how much the recognition can be improved. We will also perform a perceptual test on human listeners to find out if the present results bear any resemblance to human recognition patterns. That's all. Thank you.